All right, so previously what we looked at was how to take a stack and implement it in Python. So this involves certain operations in terms of pushing onto the stack or inserting elements or popping elements off the stack, removing them. In addition, we looked at how some secondary operations in terms of printing what the stack is, getting its size, checking to see if it's empty, getting the top element, or reversing the stack. The next thing we want to do is just to get the minimum element from the stack. So we'll add another method and let's call this get min, and we want to take the stack and we want to get the minimum. So we'll have to figure out how to do that. Now, one way of going about this is to use another stack that keeps track of what the minimum is. So we might create, whenever we initialize a stack or construct it, we'll say, all right, we're going to create an empty list here. And this empty list, this stack that we're about to create, will keep track of what that smallest integer or number is. Now, the way to create this is that whenever we push elements onto the stack, we need to track what that minimum element is, and we'll keep track of it by also not only putting it on the main stack when we construct our stack, but also pushing it on the minimum stack. So let's try to do this. What we can do is to say, well, whenever we add an element to the stack, let's check our minimum stack. And let's check to see if that minimum stack is empty, in which case we want to add our element to that stack. Or if the element is less than or equal to the smallest element in the stack. And for our purposes, it will be the last element on the stack. So it'll be the element on top. And if that's the case, then what we want to do is append that element. Okay, one more time. So when we go about inserting elements on our stack, pushing them onto our main stack, we want to check to see if our minimum stack is empty. If it is, then we want to add that element to our minimum stack because it would be the smallest number. Or if the element that we are pushing on the main stack, if it is less than or equal to whatever the minimum element already is on the stack, on the top of the stack, and then if it is, then we want to append it to the stack. It would be the new minimum. Let's think about how this would work here. So let's say we have our main stack, and then we have a minimum stack. So we just want to illustrate how this is all working. And let's say we go about adding elements to the stack. We had a 7, a 6, a 5, another 7, and a 4. Now we want to keep track of what the minimum is as we are adding 7, 6, 5, 7, 4. And so whenever we add an element to the stack, we want to check this minimum stack. In the first case, since the element that we're adding is 7 and there's no minimum, we want to push 7 onto the stack. Then when we push a second item, we want to check. Is 6 less than or equal to the element that's on the top of our minimum stack? Since 6 is less than 7, we want to add 6 to our stack. Now, if we're ever asked what's the minimum element, we can always get it from the top of the stack. So after we've added 7 and 6, we can say to the main stack, we can say, well, what's the minimum element in the main stack? Let's just check the minimum stack and it'll show us that it's whatever the top element is. So let's continue. We add 5 to our main stack. Since this would be less than 6, we would add it to our minimum stack. Now when we go to 7 here, we push this. Since it's not less than or equal to 5, we can ignore it. And then when we go to 4, we would add that to the stack as well. And let's add one more element to the stack just to illustrate something. Let's say that we add one more 4 to the stack, and 4. Now, if we ask once we've created our stack, what is the minimum element, it will be the element that is on the top of the stack here, which is 4. But what about when we start removing the elements from the stack? We might say, well, when we start removing the elements, maybe we'll run into an issue. Don't we need to do something special if we are removing element for the stack? Well, let's go down to this pop method here, which is the removing element from our main stack. and only remove elements from the main stack if certain conditions are met. So let's take a look at this pop method. So what the pop method is saying is if our main stack here, which is defined up here, is not empty, so it's the length of it is greater than 0, then what happens is the element is popped off. But what we also want to do is something else. We want to check something. We want to check to see if the value that is being popped off is equal to the minimum item in the stack. So let's illustrate that before we code it up. So let's say we go about removing elements from our main stack here. So if we remove 4, what we want to do is to check the minimum stack. What's the minimum number? And if the minimum number is equal to the number that we're removing or popping from the main stack, then we also want to remove that element from the minimum stack. So if we remove 4 here, since 4 is equal to 4, we would want to remove it. When we remove 4 here, we would also want to remove it from the minimum stack, since those two are equal. And notice that this will keep track still of what the minimum value is, because imagine if we were to ask, what is the minimum number in the main stack? Well, it's 5. Well, the minimum stack still keeps track of this fact, because when we ask the minimum stack, what is the minimum number, that number is going to be found on the top of the stack. Now let's imagine if we remove 7. Since 7 is not equal to 5, then we don't have to remove it from the minimum stack. Again, if we ask what's the minimum number, it's going to be the one that's found at the top here. Now imagine we pop 5. Well, since 5 is equal to 5, we'll remove it. Notice again, if we ask what the minimum number is, it will be found on the top of the minimum stack. So what we want to do is we actually want to get the element that we are popping off from the top of the main stack. And so we'll say, let's just define it as the top is equal to the self.data.pop. And in doing this, we're also popping the element from our main stack. So whenever we're popping that element off, we're also defining in terms of this variable. And we want to check to see if we should also remove this from the minimum stack. So we should say if top is equal to the top element on that minimum stack, then if that is the case, then we also want to remove it from the minimum stack. So we would say self.min stack, we want to remove it from that minimum stack. And in this case, what we would want to return now is not another element that is popped off, but we actually want to return this element, which is item being popped from main stack. So we want to return this top down here. Okay, so this should take care of the push and pop aspect and also keep track of what that minimum item is. The only thing that we need to do next is simply be able to get that minimum value. So to do this, we can do the following. Remember that the minimum element is going to be the element on the top of the minimum stack. And so we could say if self.min stack does not equal an empty list. So if it's empty, then obviously we can't return a minimum element because there's nothing there. We want to just return self.min stack. We want to return that top element. So whatever's on the top of the list, that's what we want to kind of return if we call this minimum method. Otherwise, what we want to say is something like, well, there is no minimum. And then we want to return nothing. So let's try to test this out. Let's say we have a stack here and let's push some numbers on there. Let's push a couple things. Let's say 4, 1, and 2. And then let's push one more number. Let's push 8. Now, after we push these elements on, we can get the minimum. So we can say of our stack here, we want to get the minimum and we want to print out whatever that is. So let's get the minimum as we're adding to the stack. And so what we should get at each point is here, since we only have 3 on our stack, the minimum should be 3. At this point, the answer should still be 3 because we'll have 3 and 4 in our stack, but the minimum still would be 3. Then we push a new minimum. So when we go to print it out, the minimum number should be 1, and then it should stay 1 as we add on 2 and then 8. So let's check to see if we get this sequence of numbers here. And just for, yeah, let's go ahead. So that's what we get. We get 3, 3, 1, and 1. Now let's go about popping elements from our stack and seeing if it still correctly keeps track of what the minimum is if we start popping elements off. So now at this point, if we push 3, 4, 1, 2, and 8, our stack should be 3, 4, 1, 2, and 8. Now let's pop some elements off, and let's pop it off. And then once we pop it off, we also want to print. No, we don't want to print. We want to get the minimum, and we want to print out whatever that is. So when we do the first pop here, it's going to take off this 8 here. And so when we get the minimum, it should check to see what the top element is, or the minimum element is in the stack. And the answer should be 1 still. So let's see if that's what we get. And that's correct. We get 1 here. Now let's pop off another element and see if we get the same thing. So if we pop off another element, which would be 2, that would be the result of removing the next one. Our answer still should be 1. And that's what we get. We get another 1. Now when we go to pop off the 1, our answer should be a little bit different because we will have removed the 8, the 2, and the 1. And so the number that would be the minimum here would be 3. And so let's see if that's what we get. And that is. Let's pop off another number, which is 4. And so if we print the minimum, since we're removing that 4, the answer still should be 3. So let's see if that's what we get. And that is. Now let's pop off the 3. So at this point, there's nothing in our stack. And so what we should get is none, and our little message that there is no minimum. So let's see if that is the result. Yes, there is no minimum, and it's returning none there. So this is how you would add this secondary operation for getting the minimum in a stack. In doing so, what we did was we built up the stack, and then we used this secondary stack here, which kept track of the minimum number, and we pushed and popped off of that minimum stack when the right conditions arose.